In this video, we're going to take a look at moving the state of a virtual machine with a feature called vMotion and moving the hard disk files from one location to another with a concept called storage, vMotion. Let's begin. I'd like you to imagine that you and I have been put in charge of the maintenance and monitoring of these three ESXi hosts. Host number 1, 2, and 3. And upon looking at some of our log files, we notice that the host ESX1 has been reporting temperatures of like 98 degrees. Now, if you're working in Fahrenheit, that's really not a huge problem. However, if it's 98 degrees Celsius, something is terribly wrong. So upon further investigation, we discover that the cooling fans on that ESXi host are not spinning. And that's causing a lack of airflow, which is probably contributing to the heat problem. So what you and I decided to do is to repair host ESX1. Now, we may have some spare parts, or we may have a maintenance company, or it may be under warranty, but that isn't the biggest problem. The biggest problem is it's 2 p.m. in the afternoon, and we have a critical server running as a virtual machine on that ESXi host. Let's call it server X for extra important virtual machine running some type of a critical business application. So what do? Well, we could wait till the evening, till there's downtime. But one of the benefits in a virtualized environment with vSphere is we could use a technique called vMotion, and we could, in real time, move this virtual machine, which is currently running on host ESX1. We could move server X over to a different ESXi host while that virtual machine is running. And they call that feature vMotion. And let's take a look at how that works for a moment. This server X, as it's running, may have, for example, 5,000 thoughts in RAM, which is a fancy way for saying memory. RAM is an acronym for Random Access Memory. And I realize that computers don't really have thoughts. They're just processing thousands and thousands of things. So if this virtual machine, server X, has 16 gigabytes of RAM, and it's got 5,000 things going on inside of that RAM, we could refer to that as the state of that virtual machine. And what vMotion is doing is taking the state of that virtual machine, which we'll refer to as the 5,000 thoughts that are currently happening in real time in RAM, and it's making a replica over on the new ESXi host that's going to be the new host for that virtual machine. So it copies all of that state information over, and then once it's completely synchronized between ESX1 and ESX3 for server X, the system will hand over control to host ESX3, and now server X will be running as a virtual machine here on host ESX3, and it will no longer be running on host ESX1. And the cool thing is this, it is virtually transparent to anybody who's currently using server X. So the good news is, once we do that vMotion, and we take any virtual machines that are currently running on ESX1 and we move them to other ESXi hosts, we can then go ahead and take down host ESX1, do the maintenance, get it all corrected, and then we could use vMotion again to move server X from host ESX3 back over to host ESX1 to help distribute that load. So what's our takeaway from this? The process of moving the state of a running virtual machine is called vMotion. And we can do vMotion in a couple different ways. We can do it manually, which we just described, where we told the system, hey, we want to move server X from host ESX1 over to host ESX3. Click a couple buttons and it's done. Or we could use a feature called DRS. And DRS is a method of automatically moving virtual machines. And DRS, the acronym, stands for Distributed Resource Scheduler. And DRS is simply an automation feature that uses vMotion. So in a healthy environment where we have all three ESXi hosts up and running and able to work, and we bring up brand new virtual machines, DRS can take a look at the utilization of the existing ESXi hosts, and it can dynamically decide which ESXi host a specific virtual machine should come up on. So let's say, for example, that we're going to start 10 virtual machines. It might start the first one here, and the next one here, and the next one here, and the next one here, and so forth. So DRS is distributing the virtual machines across the ESXi hosts in our vSphere environment. Another really cool feature about Distributed Resource Scheduler is that it's going to periodically look at the utilization on ESX1 and 2 and 3. Now, if each of these virtual machines, 1 through 9, are all using the exact same amount of CPU, that indeed would be a fairly evenly distributed load, which is the responsibility of DRS. However, if some of these virtual machines start using additional CPU, maybe host ESX1 goes to 95% utilization, and host ESX2 is at 25% utilization, and host ESX3 is at 30% utilization, all regarding CPU in this example. And what DRS could do, after looking at that, it could say, well, I'm going to go ahead and use vMotion to move a couple of virtual machines around. Maybe it takes VM number 7 and takes it off of host ESX1 and moves it over to host ESX2. And maybe it takes VM number 4 and moves it over to host ESX3. So now host ESX1 has one fairly busy virtual machine, while at the same time, host ESX2 and ESX3 both picked up additional VMs to help balance that load. So maybe this guy went down from 95% to 85%, and host ESX2 went to 30%, and host ESX3 went to 35%. And inside of vSphere, we can specify how aggressive we want DRS to be as it balances the load across the ESXi hosts we have available in our vSphere environment. Another really cool thing about distributed resource scheduler is that if we add another ESXi host, so let's add ESXi host number 4, DRS would see that additional resource, and DRS could identify that this host, host number 4, is not very busy at all, and maybe it migrates one VM off of host ESX3 over to the new host, grabs one from host ESX2, moves it to the new host, and moves one from host ESX1 and moves it over to the new host. And it's using vMotion for each one of those. And again, with vMotion, we're talking about the memory and state of a current running virtual machine. Now, in addition to the state of a virtual machine, referring to its memory and everything that's currently going on, there's also some files associated with each and every virtual machine. And these virtual machine files are kept in a location called a data store. So whenever we see the word data store, we're referring to some type of a storage device. Now, a data store, from an ESX perspective, could be either a locally attached drive. So we have a local attached hard drive on ESX1, maybe one over here on ESX2, and another locally attached hard drive on host ESX3. However, in most environments, if we have several ESXi hosts, most of those environments are going to use some type of a network-based storage device, such as an iSCSI-based data store or an NFS-based data store, to store the actual files for each of the VMs. When we create a brand new virtual machine in a vSphere environment, using the ESXi host as a hypervisor, during the creation of a virtual machine, it's going to ask us, hey, what do you want to name this virtual machine? And where do you want to store this virtual machine's files? So during the install, if we said, oh, we want to store it on the iSCSI data store, the ESXi host would go ahead and create a folder for that server. So if we name the virtual machine server X, it would create a folder called server X on that data store. So the data store is where the VM's files are kept. And inside that folder, if we gave this virtual machine a virtual hard drive of, let's say, 500 gigabytes, it would create a hard drive file in that folder for the virtual machine. So from the virtual machine's perspective, it might think that it has a 500 gigabyte hard drive. But in reality, that hard drive is being represented by one or more files on the data store. So server X is blissfully unaware of those details. It just thinks it has a hard drive. It makes read and write requests to that hard drive. And the hypervisor is the actual device that's writing to and from the data store on behalf of the virtual machine. And if we are doing thick provisioning, as we talked about in our previous video, thick provisioning for a hard drive means that we're actually going to tie up 500 gigabytes in our data store if a virtual machine has been allocated a 500 gigabyte hard drive. Or if we use thin provisioning, we're only going to use up as much space in our hard disk file as the actual virtual machine is using. So if the virtual machine is only using 125 gigs in the hard drive file, it would only be about 125 gigs in size, matching the actual used space of the virtual machine on its hard drive. Now, in most corporate environments, we are not going to be using the local data stores on each of the ESXi hosts as our primary storage location for virtual machines. Instead, we're going to use a network-based storage device, such as an iSCSI data store or an NFS data store or fiber channel over Ethernet data store. And here's a really great reason why. Let's say we have server X that's currently running here on host ESX1. If for that virtual machine we had told this hypervisor to go ahead and use the locally attached data store, what happens if host ESX1 has a complete failure? Well, not only did we lose server X because the memory state is completely gone if ESX1 fails, but because the local hard drive had that virtual machine's hard drive files and configuration files, it makes it really tough for one of our other ESXi hosts to reinitiate and start server X, because the new ESXi hosts don't have access to a hard drive that is no longer available. So for the benefit of having good availability, usually we'll use network-based storage as the location for the data stores for our virtual machine files. Now, in addition to the hard drive file for server X, there's also going to be config files. For example, a configuration file regarding server X would indicate how much random access memory that virtual machine believes it has, or how many network adapters, what type of network adapters, what type of interfaces does it have, what type of video card does it have, what kind of CPU does it have. All of those details regarding server X are contained in the configuration file for server X. And one of the benefits for keeping our virtual machines files on a network-based data store, like the iSCSI data store, is that if host ESX1 completely fails, we can go to another one of our existing ESXi hosts, which also have access to that same shared data store, and we can tell one of those other ESXi hosts to go ahead and restart up that virtual machine. And let's say it's ESX2 that's been given that responsibility. Once ESX2 brings up server X is now up in minutes. There's also a feature inside of vSphere called high availability. With high availability, we identify our critical machines. For example, server X. We say this is a critical machine. We want to use the VMware feature of high availability, HA. And once we've configured our vSphere environment to treat server X with high availability, it's going to keep, VMware vSphere is going to keep an eye on server X. And if it identifies that it's no longer running, for example, because of a host failure, because ESX1 failed, one of the other ESXi hosts will automatically restart that virtual machine, which could have it up and running, for example, on ESX2 or ESX3 in just a matter of minutes. And one of the critical requirements for using the feature of high availability is network-based shared storage. We need to make sure that ESX2 or ESX3 or other ESXi hosts that we have in our vSphere environment have access to the hard disk and configuration files of server X so they can now host that virtual machine. I'd like you to imagine that we have a team of administrators and we're bringing up new virtual machines all the time. And let's imagine also that we have two network-based shared data stores on iSCSI System A, and then we have a second network-based data store on iSCSI Storage B. Now, one of the cool benefits about creating new virtual machines is if we're using DRS, Distributed Resource Scheduler, we don't have to tell the system exactly which ESXi host that we want to go ahead and start this VM on. DRS can go ahead and take a look real time when we bring up a new virtual machine, and it can identify the least busy ESXi host, and it can go ahead and choose the right ESXi host for us. So that's cool. But what if all of our administrators are choosing data store A as their data store for the new VMs? Is it possible that if every administrator chooses data store A for the files for the VMs, that data store A could go to 95% utilization and data store B might be at 5%? The answer is, it is absolutely possible. The solution to that problem is either educating the administrators to look before they choose a specific data store for a virtual machine, or we could use a feature called storage vMotion. Now, we already learned that vMotion is moving the state of a virtual machine, from example ESX1 over to ESX3. And we can do that while the machine is running. It's virtually transparent to the end users who are using that system. And storage vMotion is moving the files for a virtual machine from one data store to another. And it can also be done while the virtual machine is running, and it can also be virtually transparent to anyone using that system. So as an example, let's say we have these 15 virtual machines that are all running across multiple ESXi hosts, and these first 12 are all using data store A. Using these storage vMotion, we could identify that we want to take, let's say, 7 through 12, and we could tell the vSphere environment that instead of using data store A for these virtual machines, we'd like to use data store B. And it will dynamically move the files, the hard drive files and the configuration files and the log files used by those virtual machines from data store A, and it will dynamically move them over to data store B. And that's referred to as storage vMotion. So vMotion all by itself is about moving the state regarding a running virtual machine, the memory, from one host to another. And storage vMotion is moving the files from one data store to another. Now, as you can imagine, it may be kind of tricky in a large environment to keep track of all the data stores and their utilization and who's using what. And that's why there's an additional feature if we want to automate the process of storage vMotion. There's another feature called storage DRS. Now we know that DRS, Distributed Resource Scheduler, is moving VMs across ESXi hosts dynamically based on evening the load. Well, storage VRS is that same concept, but regarding data stores. It can take a look at all the data stores in something referred to as a data store cluster, a group of data stores, and it can, on its own power, dynamically move the files, the hard disk and config files for virtual machines from a very overused data store to a less used data store. And that can be done dynamically with storage DRS. Now, one of the challenges I want to make you very critically aware of is that when we start moving data in large quantities, maybe we have a virtual machine with 16 gigabytes of RAM or a virtual hard drive with 200 gigabytes, moving that data takes large amounts of bandwidth to do it in a timely manner. And for that reason, vSphere best practices is going to have a separate network for vMotion services. And in today's high-speed environments, it's very likely going to be 10 gig or better. So that would involve additional Ethernet interfaces on the ESXi host that are used exclusively for vMotion services in moving data very quickly on dedicated networks for that purpose. So in this video, we've identified the following. Number one, a data store is where the VM files are stored. And in most environments, for the benefit of high availability, we're going to use some type of a network-based storage, such as an iSCSI-based data store that's accessible by all of the ESXi hosts in our environment. vMotion is the process of moving the running state of a virtual machine from one ESXi host to another, which could allow you and I to do hardware-based maintenance on ESXi hosts during the middle of the day after we vMotion virtual machines off of the ESXi host that we want to work on. Storage vMotion is the process of moving the location for a virtual machine's files from one data store to another. And anytime we do vMotion, whether it's vMotion of the state of a virtual machine or storage vMotion, we want to make sure we have plenty of bandwidth available for those functions so they can complete in a timely manner. DRS is the Distributed Resource Scheduler that uses vMotion, and it does that to balance the load of virtual machines across our existing ESXi hosts. And Storage Distributed Resource Scheduler does that same type of functionality, but related to the data stores. It can evenly distribute the files for our virtual machines across the data stores that are inside of our vSphere environment. I have had a lot of fun in this video, and I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.